All right, this is page 37 to 39, and we're starting with problem number 9. So they've given you a graph of f of x, and we're just supposed to find these function values. So part A, f of 2. This just means what's the output when the input's 2. So here's f of 2. Looks like it's 0. And part B is f of 1. So when you have an input of 1, what's the output? Now there are 2 points here, right? But this means this is not a point on the graph. There's an open circle there. Instead, f of 1 is up here. So f of 1 is positive 1. Part C, f of 3. So here's 3. Now, we're not supposed to just guess at this. We can use slope. This is a line, right? So the slope is like when I'm at 1, negative 2, and then I go up 2 over 1. So the slope is 2. So from 0, I go up 2 over 1. So even though you can kind of guess that it's at 2, that is correctly at 2 because of the slope. And then for part D, f of negative 1. So when the input is negative 1, where are we on the graph? Again, it looks to be 3, but use the slope to double check. This slope is up 1, left 1, so that's the slope of negative 1. So if you go up 1, left 1 again, yeah, you will land at 3. For number 10, this is this looks like a semicircle. So with a radius of 4, centered at 0. So let's kind of keep that in mind. F of negative 4 is right here. That looks like that's sitting at 0. F of 0, so when you put in 0, where are you on the graph? You're at the top. That reaches 4. F of 2, now here's where we kind of need an equation. F of 2, where is that? It looks like it's a bit higher than 3. And I don't want to just say, oh, I don't know, it looks like 3.2. We can come up with this equation. This is a circle with a radius of 4 and a center of 0, 0. And I know that you did conic sections in Algebra 2, but even if you didn't, what you need to know about a circle is that its equation is x squared plus y squared, if it's centered at 0, 0, equals r squared, which would be 16 in this case. So what is f of 2? So when you put in 2 for x, we're asking what is y. 2 squared is 4. I'm going to subtract 4 from 16. Take the square root. Technically, y is plus or minus the square root of 12, which is plus or minus 2 radical 3, except when we're at 2, we know that we're just looking at the positive on this graph. So just plus. So I don't want to say, oh, it's 3.1 or something. It's actually 2 radical 3 exactly. And part D, f of 4, back to 0. So when you're given graphs, you're not helpless with like guessing what you have. They're going to give you something that you can write an equation for. So a little half circle might be the most complicated thing we get. Lines, we should be able to use slope in our favor. So just keep that in mind. For this section of the problems, we are supposed to be finding, I believe, just domain. Let me double check that because I erased my directions for that one. Oh, domain and range. Sorry. Okay, so domain and range. So let's start with domain. It's good to know what kind of function it is. Maybe you can even sketch a little graph. This is a negative x squared graph. It does something like this. It's been shifted down 3 units. It's got a vertex at 0, negative 3. That's important for the range. For the domain, I don't need the graph. This is a quadratic, so its domain is all real numbers. There are no fractions with an x in the denominator or even roots to mess things up. For the range, well, this graph, because it's a quadratic, it has a vertex and it's opening down. So the lowest it goes is negative infinity, and the highest it will ever reach is negative 3. And we will hit negative 3. That point is on the graph. Here's another quadratic. So without sketching it, I can say all reals for the domain. This one is a parabola that opens up and it's been shifted down 1. We're going to do transformations more formally in the next section, but you should know these just kind of basic vertical shifts here. Okay, and so domain is all real numbers. Where's this vertex? It's at 0, negative 1. So the range, the lowest this graph will reach is -1, and then it goes up to infinity beyond that. Now, radical 16 minus t squared, we actually just looked at this. That's what this equation is. This is x squared plus y squared equals 16. But if you were to solve that for y, you get 16 minus x squared. And because this is the top half, so all of these y values are positive, y would equal the positive square root of 16 minus x squared. So we already know what this graph looks like. And this is a pretty common equation where it's the square root of basically a difference of squares. It could be 25 minus x squared, 1 minus x squared, 100 minus x squared. You need to know that that is a half circle. And you need to know how far it spans based off of this number. So square root of 16 is 4. It's going to go from 4 over to -4. That helps me with the domain. So domain goes from -4 to 4. And then the range, what's the lowest y value on this graph? It hits 0. And it does have a highest value. This is a circle, so the highest it will ever reach is +4. All right, and again, absolute value graphs, we need to know about these. We're going to talk about them more formally in a day or so, but you need to know this is an absolute value graph that's been shifted to the right 5 units. It opens down. It's got like a slope of plus or minus 1/4 on each side, something like that. There's no limit to what we can plug into an absolute value graph, so all reals for domain. For the range, it's like a parabola. It has a vertex here, and it opens down in this case. So it's going from -infinity up to, what is that y value? That's 0. But it never gets higher than that. Okay, for number 20, we've got parts A through F for this one. So they're giving us this graph, and they even told us equations. This is the line x plus 4, and this is the half parabola 4 minus x squared. So what is the domain here? Well, the domain is x less than or equal to 0, and then also x greater than 0. That just spans all real numbers. There are implied arrows on both of these ends. So the domain is all real numbers. The range, both of these continue to decrease without bound, but we hit 4 as a high point. So -infinity to +4. What are the values of x for which f of x equals 0? So draw a horizontal line going through 0 and write down the two x values where we cross. So it looks like x equals -4, and also this one tick mark represents 2 units, so -4 and 2. This, by the way, is a pretty common part of an AP question. Super easy. Just here's a graph. Tell me where f of x equals 0. Or they could ask for f of x equals anything. You just draw a horizontal line through it. Find that answer. What is f of 0? When you plug in 0, you get an output of 4. Find the value of f at x equals 1. Give us coordinates. So at x equals 1, right here, that's at x equals 1. What's the y coordinate? 0. So f of 1 equals 0, but give us coordinates. So that means that when we plug in 1, we get 0. And what is -3? F of -3. So now that's not a nice point that's on our graph, but again, we're on a linear segment, and they gave us the equation for this. So your f of -3 is just equal to x plus 4, so -3 plus 4. So that's equal to 1. So it's -3, 1. All right, and then I didn't erase my work for these, so I'm just going to keep this up and talk through it. So 21 said to find the zeros and the x-intercepts or something like that. So -4, x equals -4 and x equals +2 are the zeros of f of x. You can also call those x-intercepts of the graph. And I'm not sure why why this line is up here. Okay, and then for 22, f of 0 equals 4. That would be the y-intercept, where you're crossing the y-axis. All right, now this question is kind of in regards to if you're using a graphing calculator, so I'll leave that up there. But it says use the vertical line test to determine whether y is a function of x. describe how you can use a graphing utility to produce the graph shown. So this is kind of silly now that we know we're allowed to use Desmos on our AP test, because you should be able to, let me just double check on this. You should just be able to type them in as you see them. But what I have written down is what I would need to do if I were in my graphing calculator. So if I'm using my TI-84, I would need to solve the equation for y, and then on two separate lines, because there's a plus or minus, type in two separate lines into my y equals. Same thing on this one, kind of complicated solving. But let's just see if we can just type them in Desmos exactly as they are without rearranging anything. Yeah, so there's that graph. I can see that's not a function because some inputs have two outputs. And then what about this one? X squared equals 2xy minus 1. Yeah, so much easier. Desmos makes life a lot easier. I love my TI. I used it for years and years and years. But we're allowed to use Desmos on our state tests and our AP test and the digital SAT and ACT. So it is nice to be able to use this. All right, next section, increasing, decreasing, constant. Remember, you're only giving X values, and you're only using open intervals, meaning only using parentheses. So the first graph, this linear graph, is increasing for all real numbers, never decreasing, never constant. The second graph, this parabola, where is its vertex? It looks like its vertex is at 2. We could verify that by finding the vertex of this quadratic, but I'm not going to worry about that yet. That's in our quadratic chapter. So this is decreasing from x coordinates negative infinity to positive 2, increasing from x coordinate 2 to infinity, never constant. 29 is this interesting kind of square root. Difference of squares, but when you subtract the other way, you don't get a half circle, you get this kind of shape happening. So first you're decreasing and then you're increasing. So decreasing from negative infinity to negative 1. And we're still using an open circle there because at negative 1, the graph doesn't continue to decrease. There's no point to the right of that. And then increasing from positive 1 to infinity, and again, never constant. And the last graph is increasing, decreasing, increasing. So it looks like this is at 0, so increasing from negative infinity to 0. And then also from this little point, looks like it's at 2 for an x coordinate, 2 to infinity. Decreasing in the middle from 0 to 2, never constant. Constant, you're only going to get that for in a piecewise equation. Okay, these next two questions say the direction said something like use a graphing utility to find the relative extrema. So let's go ahead and practice that again. Way easier in Desmos. So let's see. G of x is equal to negative 2x to the third minus x squared plus 14x. Now, how do I know what window to look at? I kind of don't on this one, so but I can see the graph right here. So if I couldn't see the graph, then I would maybe say, I don't know, give me g of negative 10, g to 10, and then zoom fit from there. So this graph has, zoom that out a bit, a relative min. And remember, you just kind of hover over it, and a relative max. And let me check my previous answer key. Did they want the location or the coordinate or what? The relative, okay, they want the value. So the relative minimum value and the relative maximum value. So that means that they want the y coordinate, not the x. So there's a min at, you can click on it and it'll stay there, negative 16. We always round to 3 places for our AP exam. If you round to anything differently and it doesn't instruct you to do so, you won't get the point. So get in the habit of rounding to 3 places. Negative 16.864. And then what is the max? 12.160. All right. And then what about this equation? So I'm going to X out of that. g of x equals x sqrt for square root 4 minus x. And kind of an interesting little thing there. So 3.079 is the relative max. There is no relative min because this graph looks like it continues to just decrease after that. So there can't be any relative minimum. All right. And then let's take a look at this. So modeling data. So the number in thousands of a new single family house sold each year from 2006 to 2017 in the US is approximated by this model. Domain is 6 to 17. So that gives you a nice little domain to work with. I've got screenshots of what I did, but I want to do this in real time. So for part A, it says use a graphing utility to graph the model over the appropriate domain. So let me split screen here and make this smaller. Okay, so n is equal to, now I think we might need to call it n of t. Let's find out. I'm still learning my Desmos rules as well. So there will be times where I'm like, I don't know, let's see. I've used the TIs for so many years now. Here's one where Zoom Fit is going to be handy because I can't see the graph as it is. And I don't want to go, like, if you start scrolling out and doing, then sometimes it gets pretty weird. Like, this is not helpful, scrolling out like this. So I think I need to put an N of T here because I want to put in a table next. Remember, to Zoom Fit, we're going to say, okay, we want to go from 6 to 17 for the inputs. And so just go ahead and find N of 6 and N of 17. I'm not sure if you didn't have the T there. Let's see. Yeah, see how it's like, what's happening? So you have to tell it N of T. Anyway, and then remember, Zoom Fit. So that gives us a much nicer section. We can scooch it around a little bit. We're just looking at this section here. All right, so did we do that? We did that. And yeah, my graph matches. Okay, and then it says, use the graph from part A to determine during which years the number of new single family houses was increasing, during which years was the number decreasing. So we're looking from just 6 to 17. So it looks like increasing from here to here, decreasing from here to here. So what is this little changeover point? It's 10.745. So, and remember, 6 is 2006. So for part B, I would say the number of new family homes, I'm kind of abbreviating that, is decreasing from t equals 6 to t equals 10.745. Now in parentheses, I'm going to say that means 2006 to 2010. You're still in 2010 if you're at 2010.745, right? 2010 lasts until you change to 2011. So 2006 to 2010. And then the number of new family homes, it's always good to write in context, is increasing from t equals 10.745 to, is this the end of our interval? This is not quite 17, but, well, I guess it is. I guess that is what they, oh, there we go. That's what they plotted there. So 17. So then I'm going to say from 2010 to 2017. All right, and then part C says, approximate the minimum number of new single-family houses sold from 2006 to 2017. So what is the minimum? This is asking for the absolute minimum. So I'm going to call it that, the absolute minimum. Just look at the graph and look for the lowest point. So the lowest point just on this interval is not either of the endpoints. This time it's this relative min. So what is that number? The absolute minimum number of new family homes is, I always give the decimal to 3 places. And then in this case, it makes sense to round to the nearest house. So 309, remember, it's not 309 houses, it's 309,000. Or you can add the zeros there. 309,000 houses. All right. And then this last problem, yeah, that was it. This last problem is always a bit confusing for people. There are a lot of possibilities here. So I just want to talk through this one. I'm not going to rewrite what I have. But let's take a look at this. So the intake pipe of a 100-gallon tank has a flow rate of 10 gallons per minute. So the intake pipe is the water coming in. So that comes in at 10 gallons per minute. And then there are 2 drain pipes that have a flow rate of 5 gallons per minute. So water is coming in and water is draining out. So water is coming in at 10 gallons per minute through the intake pipe, and then it's draining out at 5 gallons per minute at each of these 2 drains, drain 1 and drain 2. All right. The graph shows the volume of fluid in the tank as a function of time. So we can see the volume is like increasing, staying the same. The volume decreases, so more is leaking out than coming in. Then it stays the same for a while, then increases, same, increases. So volume is changing because water is either coming in faster than it's draining, or they're equal, or water is draining faster than it's coming in. Determine in which pipes the fluid is flowing in specific subintervals of the 1 hour interval of time shown on the graph. So they're just saying, I just saw the 1 hour interval. I don't know if they gave me like a specific 1 hour interval, but I just did the entire thing. So look at each section where you have point to point and the behavior changes, and first identify what's the slope, what's happening. The volume is increasing at what rate? So it goes up 50 gallons in 5 minutes. That's a slope of 10. So the water is increasing by 10 gallons per minute. So I'm going to open the intake valve. It's coming in at 10 gallons per minute, and it's not draining at all. So these 2 are just going to stay closed. So I'm letting water in only. I'm not draining anything. And then the slope changes. So here, now the volume is going from 50 to 75. So now the slope is 75 minus 50 is 25. In a matter of 10 minus 5 minutes. So now the slope is 5. So water is still coming in, but it's not coming in at a rate of 5 gallons per minute anymore, or 10 gallons per minute anymore. It's only coming in at 5 gallons per minute. So that means that from 5 to 10, you have to keep the intake valve open. But in order to slow it down to 5 gallons per minute, you've got to open one of the drains. So I opened drain 1 and I kept drain 2 closed. You could have switched this. That's why there are many different answers here. All right. And then if things stay stagnant, either you could open all of the drains, let the intake come in at 10 gallons per minute, but drain it at 10 gallons per minute at the same time. Or you could just keep them all closed. I just chose to close everything. If I close everything, there's no water coming in and there's no water coming out. All right, final one I'm going to talk through, and then you can kind of see through the rest of this. So what's this slope right here? That slope is negative. We're going from 75 down to 25. So that's negative, a drop of 50 in from 20 to 30. So in 10 minutes. So that's a slope of negative 5. So again, I've got to have some sort of thing to counteract this. Like I can't let the intake valve stay open because the 2 5s won't give me a negative 5. They won't overtake that. So I'm going to keep this one closed and just open one of the drains. Again, I could have done either one. I opened drain 1, I left drain 2 closed. Okay, so you're just looking at the slope and figuring out how can I make that net value with the numbers 10, negative 5, and negative 5. hopefully that helps. They're calling this a mechanical engineering problem. So you're kind of thinking outside of the box. Just trying to get you to think creatively. I thought that was a pretty good practice. On our AP test, they like to give us problems where maybe they tell us what's happening with the drains and we have to pick the correct graph, that kind of thing. All right. Come into office hours if you have any questions.